if everything works for now. Okay.
Okay, let's continue. Thanks a lot, Philip. Continue after a little pause of the streaming. We are back. Let's go. Thank you.
Okay. Then after the general overview, let's jump into the life cycle. So how does the Oracle work step by step? First off, in the life cycle, the operator of the Oracle has to register the Oracle to be available on chain. So this is from the account of the operator. Then as a second step, any account or any contract can post a query to the Oracle. This is public on chain and anybody can do it. As a third step, the operator, so again, the operator account that previously registered the Oracle, then listens to the blockchain for any query and responds to that query. And last but not least, the operator has the possibility to extend the lifetime of that Oracle. Because oracles have a limited lifetime in order to not spam the blockchain forever with their data. First off in the life cycle, as I said, is registration of the Oracle. To register an Oracle, it has to be done by the account of the Oracle or the one that will operate that Oracle, and only one Oracle per account is possible, as the Oracle address equals the account address, but with a different prefix. So any account, as you maybe have seen already, is with the AK prefix. And the Oracle will have the same address, but with a different prefix, with the OK prefix for Oracle key. Next up in the registration, you have to specify the query and response format. This is either a Sophia type that can be used in smart contracts in the Sophia language, or it can be a raw string. This means it can be used outside of contracts, but is limited to string, as the blockchain doesn't know how to interpret the data there. And this means the VM version is no VM, just as a note if you stumble over it at some point, so you know what it means. Next up, you have to specify the query fee. This is the amount that has to be paid by anybody posting a query to your Oracle to pay you, the operator, for providing the data. Either this is just the payment for, you can specify a 0, so no payment is needed, and you pay for all the transaction yourself. You can put a minimum fee so that you cover your operating costs, or you can say it's really expensive to query that Oracle if your data is really valuable. And you have to specify a time to live, meaning the time the Oracle itself will be available on chain as a spam prevention measure. And longer TTLs are more expensive as they will be available on chain longer, as I said. And you can specify a relative or absolute block height, meaning you can say it's available 200 blocks from now, or you can say it's available until block 500,000, for example. Next up in the life cycle is anybody can post a query, meaning any account on the blockchain or any contract can post a query to every Oracle that's available on chain. And to do that, you have to provide the query, either from the contract or using a raw string again in the response transaction, Oracle query transaction. And you have to put in the fee that was required by the operator while he registered the Oracle that is specified there. Then again, you put the query and response time to live, so the time that your query is available on the blockchain for the Oracle to answer, and then the time the response should be available on the blockchain as with your query fee, you pay for both your query and the response, usually. Again, this is the time it's available on-chain, and the longer this time to live should be, the more expensive it is. So you have to know when you want to consume a possible response to your query. Then, again, you can specify this as a relative or absolute block height, as we had before. Then in the life cycle, again, from the side of the operator of the oracle, he looks on the blockchain for queries to respond to. So he observes the blockchain, sees, oh, there's a query to my oracle. I have to put a response here. And he can do that in a contract, for example. So automated data from a contract, or also manual data via a contract can be put there. And as well using the raw transaction in the oracle response transaction. And again, as we had before, you put in the response time to live from the query. And when you submit this response on the blockchain, you unlock the fee that has been paid by the query previously as an incentive to run and give answers on that oracle. Last but not least, in the life cycle, you have the oracle extend transaction, meaning the operator of the oracle can extend to the time to live, so that prolong the on-chain lifetime of the oracle by paying another fee to cover the costs of the blockchain to provide this oracle. Next up, we will jump into some examples and some live coding on how to use oracles. First example will be with a simple price feed using native blockchain transactions. Then we will have a look at how we can use this from a contract. And last but not least, some more detailed examples how we use it in Superhero to validate URLs, and some edge cases that you have to look out for when using them in a contract. For the theoretic side, are there some questions now?
Yes, Shita was asking, what is the time to live?
So the time to live for all of the transactions is the time the data that you put in is available in the blockchain. For the oracle, it's the time that anybody can post a query to that oracle, and at some point it just runs out. Maybe you don't provide the service anymore if you don't extend it, or you've forgotten about it, or you are in a maintenance mode or something like that. So the time to live is run out, and then it's also not available on the blockchain anymore. It means the data can be pruned from the chain, so it's not spamming the blockchain. And the same with the query and response data. You specify the time to live until the data can be removed safely from the blockchain. So until this, it has to be consumed or it will be gone, even though the fee has been paid.
Then there's another question. What is the default TTL for an oracle?
I don't think there's a TTL, a default TTL. You can specify that yourself. I think usually we use 500 blocks. So the TTL is specified in blocks, not in seconds. 500 blocks, key blocks in Eternity blockchain. For the oracle lifetime, and in our examples, we use 20 blocks as a TTL for the query and response. But for the query and response, and also for the oracle, it's up to you to specify what makes sense for you. Do you want to extend it more often, or you want to have it available all the time and pay a bigger fee up front? And the second part, for the query and the response, you also have to know for yourself. Will it be instantly consumed? So my contract looks instantly. Is there a result? And use that in your calculation, or you want to have some time, say 2 days, 5 days, measured in blocks, of course, in order to consume that result.
Then there's another question from earlier from Marco. What response types are supported by oracles? Is it possible to define custom return types?
Yes, in oracles, when you use them via contract, you can use any type that's available in Sophia. You can also specify your custom ones, I think. And when you use it as native blockchain transactions, using the Oracle query and Oracle response transaction, you are limited to using raw strings, as they can be understood in any scenario.
Right, let's continue with the presentation for now.
Okay, perfect. Then let's continue with the example. So our first example will be using basic and native blockchain transaction to provide a simple price feed on the blockchain. So our example that we use here is a two-part boilerplate using the JavaScript SDK, as you maybe have previously seen that is available. The first part is the Oracle operator that provides the price of the Eternity token when you query for it. So in our example, a repository that I will share later, this is in source operator, just if you want to have a look later on again. And this creates a new account and waits for initial funding to be paid. So the account of an Oracle needs some initial AE tokens in order to first register the Oracle, as we've learned, and when there's the first query, provide the first response, because only with a first response, you get paid back from the queries. And then it's mostly self-sufficient. And usually for oracles, we want to create separate accounts and not reuse your existing ones. Just security is not so much needed there. And you can only have one oracle per account. So we just create a new one here. Then next up, we register the oracle using raw string query and response format. And then our example listens for query transactions containing the currency as a parameter to return the eternity price in. For example, you can query with BTC and then you will get the eternity price in Bitcoin. Or you can query EUR for euro and you will receive back the eternity price in euro. And then our example uses the CoinGecko API to get the price from the internet and then post this as a response transaction to the blockchain. And periodically we check, is our oracle expiring soon? If so, we make an exchange transaction. That's the first part of the boilerplate example that I will go through soon. The second part is the Oracle query example. So also in the repository in source user query using SDK, you find the example code to initialize any given, or to initialize the Oracle to load it up. Then to post a query, specifying the query fee, the TTL for the query and response. And then you poll for responses to that query if given. And this is the repository just for later use. I will jump into it right now. So first, in the source operator index, we find some boilerplate in JavaScript. I think it's big enough. I hope so. And here we made an object. This is the price feed oracle. We initialize it, we register it, and then we start polling. Let's have a look into what these functions are doing. So first, with the initialization, we initialize Eternity client, and then we await for funding. So will our oracle be funded, or when it gets the initial funding, so that we know everything is fine from there on. Then next up, we use the register function. Here we specify our query fee. This is in Ethos, so this is 0.002 AE, I think. It's the fee you have to pay in order to query that oracle. We use here the JavaScript SDK to call the get oracle object with our public key. We replace the AK with OK and see, is there an oracle already defined for that key? If yes, we use it. If not, we register a new one. So we use the register oracle. We provide string as a query format and string as a response format. We pass our query fee. And we pass our TTL, which is this.ttl. And I specified 500 as a TTL for this oracle. Then we log out for the oracle. And we have here some logic to extend it if it's needed. And if it's needed, it will just post oracle, extend oracle again with the same TTL. Just if it's needed, if the time to live is running out. And then what we do is we call the start polling. So we look for queries to our oracle. And for this, we can use the oracle.poll queries, passing the function how to respond to that oracle, and the interval. So every 2 seconds, we will check for queries. You can also use the WebSocket API from the middleware, for example, for this. This is, of course, possible. In our example, we just use the SDK and the manual polling function. And then once we receive a query, the respond function is called with a list of the queries. We just look for the most up-to-date query. We look if it has some data attached to it. Maybe it does not, just a basic check. We decode the query here. This is not so nice right now because this is the raw string queries. But of course, this will work here. We got the query, which is the string. We use that string, which is in our case the currency, to fetch the eternity price in, to call the CoinGecko API. So we call CoinGecko API CoinGecko.com price eternity versus that currency. We look up the result, and if we have a result, we will call Oracle respond to query, passing the query ID, put in the response with the response TTL. And here's also some functions that we don't use right now to stop the polling and to look, is our Oracle running right now? If you copy that code in your own projects, for example, or if you reuse it to provide another Oracle, this can maybe be helpful. So let's have a look what it does. First, I will remove my old key pair in order to show all the process. And I will run my Oracle using that index function. So first thing that it does, it says fund the Oracle with 0.01 AE, and this is on testnet. So I will take the wallet on my phone. Will it work now? Of course, it won't detect the QR code because my terminal breaks it a little bit. But let's copy it here. I will just quickly go to the browser. Go to my superhero wallet, switch it to testnet, and send to that account 0.01 AE. Send that. And then look at what my Oracle will do. It says received funding, Oracle client initialization with TTL 500, auto extend true. And now it's running. And it's checking. It started the poll query, the query polling, and it says no need to extend the Oracle because it's still up to date. If I then, what this does is it saved the key pair to the disk in the data key pair folder. So if I am going to restart my example here, it will already know the oracle, and it says my oracle is the OK46Y8 and so on key. I will copy that for later use. So now what we can do is we want to make a poll to that oracle, of course. So for this, there is in the user folder the query using SDK. What we do here is we again initialize. Oh, the one in the bottom is a little bit small, maybe. We initialize the new object where we initialize again a client to the Aeternity blockchain. We initialize the oracle, which is now this one. And then we can make a query for the AE price. So the initialization of the oracle is again Aeternity client, get oracle object with that ID that our oracle is registered at. And then to query for the price, we do oracle post query, post the currency that we want to query in, and the query fee, which is this oracle query fee that we can get automatically. And optionally, we can specify different time to lives here. I use the default, it falls back to 10 using the SDK. And then next up, we do poll for response, or query, poll for response. And then once we have a response, we decode it. So response.decode. And let's run that again. I have it here. So when we run that, this has a different key pair attached to this, which I've put in as an environment variable. So it says it initialized the oracle. So this means it read the blockchain to fetch what's this oracle information. Then it posts the query. So it posted the query for euro as a currency. And this is the query address. And it checked as well for the oracle, and it says the current price of Aeternity token in euro is apparently 0.203891 euro. So 20 euro cents currently as the price for an Aeternity token. And we can look at our oracle that was running, and it said it got an oracle query for euro, and our oracle will respond with that. And this is what we got here. So this is the first example how we can create the operator side of the oracle and the user side of the oracle, both in the JavaScript SDK to do the full oracle system lifecycle. So the one that we've spoken through earlier. And you can find the code here, and we will later share, of course, the presentation if you want to have a look back at this. Are there any questions for this example for now?
I'm not sure if it's related to this example, but there were open questions. Isn't CoinGecko itself acting as an oracle, passing some data back to us? What is the use of the oracle that we are writing?
Yes, so the use of the oracle is to provide the blockchain, to provide the data on the blockchain. For this, we use the CoinGecko API, and CoinGecko is the oracle here. But we cannot call the CoinGecko API in our smart contract. There's just we cannot make a HTTP call in our smart contract. And if we need the data on the blockchain to be then used in some calculations in my smart contract, for example, we can fetch the data using an oracle. And with this example, we provide the data from the CoinGecko API in our oracle format. And you can provide, of course, any data there. I just use CoinGecko as it's a good example. Ideally, what you want to do is provide your own data that you generate and that's important to someone else, or that's important for you to reuse in your smart contract and to provide publicly.
Then there's also a question, is there also an example of an oracle that triggers a smart contract based on an external event?
So we will go into using oracles with smart contracts in the next example. But to skip ahead, it's not possible to trigger contracts using an oracle because you don't know what's the caller account in this case. And this can be a vulnerability if you just use the original caller or hard code some account to be called from. And of course, the oracle can spend some fee, meaning, or can take some fee. It means it could spend money from an account. So triggering is not possible. You will have to do that manually.
And then I guess this question was already answered. How do I await an oracle response in a smart contract?
Yeah, I think that's the same.
Yeah.
Same answer. Then let's go and skip ahead to using the same oracle that we had before, just how we use it in a smart contract to query the oracle result in a smart contract. First, the thing we have to do is find out what is the query fee. Then we have to again send the query including the query fee, or we can of course also use the balance of the contract to provide the fee if the contract owns some balance. And we have to check back later for the query result. And this is also in the same repository. So here we have the price feed query Sophia smart contract. And we will use AE Studio. I just pasted it here. I will switch to use my extension. And then we can deploy our price feed query smart contract. And this will fail now. Oh. Can you still hear me?
Yes.
Okay. Just AE Studio crashed for some reason. Let's go back to AE Studio. We have to provide price feed oracle. We have to provide when we initialize our oracle, when we initialize that thing here, our basic example smart contract, we have to provide the oracle that we want to use. So I provide the oracle that I started in JavaScript in the example before. We deploy it. Let's wait for it to be deployed on testnet. Here it is. We can check what's the query fee. And for this, we call the query fee function, which just uses oracle.queryFee and the oracle we provided earlier. And this returns us the query fee that we specified earlier in our JavaScript oracle. Then we can query the AE price for the currency. So the same example that we had in JavaScript. Now we can use it from Sophia. First, let's find out the fee again. Then we check is the amount that's paid by the one calling the smart contract equals to the fee that is required by the oracle. We check is the currency the correct length here. So is it 3 digits? And we do oracle.check the oracle. So is our oracle still available? Is the format the correct one that we expect, and so on? It does a number of checks. And then it runs oracle.query, our oracle, the currency, the fee, and also the query and response time to live as a relative TTL here of 20. So let's copy our query fee, put this in here in the top. Oh, I have to switch to the extension to use that. Let's put it here in the top. And then we can query for price. Let's do the price of aeternity in USD now. We can send the transaction. And here we get the query ID as a return value. Let's make it a bit bigger. We get the query ID as a return value. And then later on, we can statically call check query to call Oracle get answer for that ID. Let's put the value back to 0, put in our query ID that we can check, and we get the price in US dollars, 0.24 US dollars is the price for 1 AE right now. And this is using the example Oracle that we had earlier, and that's running here locally on testnet, and using that result from the smart contract. So here we see Oracle got the query for USD, and the Oracle will respond with that value. Are there any questions for this? If not, the next example will be how to use multiple oracles in combination, and also for some edge cases.
There's a question from Alexander. Is our OK underscore hashtag a constant once written? Is it a bad practice to build an oracle directly into our smart contract?
So OK is the account of that oracle. So if you use the account with a public key AK something, then the oracle will have the same public key, but with a different prefix. So if you, with that account, again, register an oracle, it will be under the same address. So therefore, it's a constant. But what you might want to consider is, in the future, you want to change maybe the data provider for in your contract for that oracle. So maybe you want to have a function in your smart contract to change where or what oracle to query, or maybe even query multiple oracles if they are available, just to make sure if you maybe change your data provider that you are able to. And this can also be a feature. If you have your smart contract there and you want to provide different data, all of a sudden you can provide different data using the oracle, not be stuck to that single source of data that you have maybe already built in your smart contract.
And then there was also a question from Marco. Is it possible to aggregate prices of responses from different sources within the smart contract?
Of course, that's possible. We will jump into the use case with multiple oracles as the next step.
Yeah, I think that's all for now.
Okay, perfect. Let's jump into the example. So we can use multiple oracles in order to provide a more decentralized result. Using one oracle is very good for where there's a single source of truth. For example, for an exchange price, if I want to get the price of CoinGecko, which is a single price, I'm best off querying CoinGecko directly. And if CoinGecko would provide the first-party oracle, we can see this is the data of CoinGecko, and this is exactly what we wanted. But if we, for example, don't know, is CoinGecko the correct price of our token, we can use multiple oracles that provide, for example, pricing information from different sources. Or, this is my first example here. We can query multiple exchanges for the price and, for example, use the average price as a trusted result. Or we can say we discard the highest and the lowest results and just use the mean result or something like this as our exchange price to then use. Another example would be to query different data or the same data from different oracles to see, do they all provide the same result? If only all oracles provide the same result, for example, who won an election, if everybody says Joe Biden won the US elections, then you can trust that result probably, if all of your decentralized oracles give the same result. And you can make then a decision in your smart contract based upon this. Or you can receive multiple different responses from various oracles and see, do they match up? Do they Do they differ in some way, and just see what's the result. And maybe you want different results. For example, what's the weather to build and to make some things on the weather. But of course, the weather is different for everybody. It's not everybody will provide the same weather. And the first thing that we want to do here is we want to check the oracles before we use them, and we want to filter for that check. If an oracle is not available anymore and we try to query it, our contract will crash. So let's make a check. Is that oracle still available? And is the formats of that oracle, is that all the same? And of course, check the fee. So we check if the types match, we check if the oracle is still available. And if we don't check it, the whole call may abort and we may be locked in our logic. The second thing that we want to do when using multiple oracles is checking what is the price of each of the oracles and provide the total price for all of the oracles to pay everybody, of course, that is involved in giving that answer. And what's usually a good practice is check if the provided amount is exactly equal to the one that's needed, so that you don't have an overflow of unspent or unused tokens in your contract that you maybe cannot get out anymore. And then when you want to query that oracle, check again using query.check or check query for the query. So maybe an oracle has not responded yet because it's not available for some reason, even if it's, as it said, it would be available, or it couldn't respond for some reason. Then you don't get a query. And then you can filter for that. Again, if the response is not available on chain, maybe the TTL has run out, it was too short, or the fee has not been paid, it was out of funds for some reason. And if it's not checked and filtered, your whole call again may be aborted if one of the responses fails. And then you have all the results from all of the oracles. You can gather those and aggregate those eventually. And we use this in the tipping oracle service for superhero.com, and we will also jump into the code here. So the first thing that we do here is we estimate the query fee. So we use estimate query fee, where we aggregate the fee, query.fee, for each of the oracles. And we use a list of checked oracles that I will get into next. Here is the checked oracles. So for each of our oracle that we have in our state, we have in our state a list of trusted oracles, and we call check oracle function. And then we check again, is it more than the required oracles? Because we say this is a minimum amount of oracles required. And then to query that oracle, first thing we do is we call the estimate query function that I showed earlier. We see is our query fee that we expect actually matching to the value that has been provided in that call. If so, we will continue. We will build our query string. So in Superhero, what we do is we use it to check, does a specific URL contain a specific account public key? So we use, as our query string, we just concat the expected account, a semicolon, and then the URL to check for the oracle. And then we execute all of the oracles. So we define a function here, query oracle, where we pass the oracle, return the oracle, and oracle query, the query string, the fee for that oracle, and we hard code the TTL of 20 here. And then we save, we just do a list .map for where we check, where we execute that query oracle function for each of our checked oracles that we had before. So each of the checked oracles will be queried. Yes, so that we don't lock ourselves into only query the checked oracles. And what we then do here is persist all of the queries. So for each URL, they can only be queried once. So for each of our URL, we save all the queries in state. And then later, when we come back to the contract, so we expect the oracles to have performed a check and given an answer, we can call a check for our claim here, which will call the check oracle answers, and here we do check oracle answers as a function that just provides a list of booleans whether the account that we found in that URL is matching to the one that we expected. So here we will check, define a function, check that oracle, check that query. So for each of the, or if the oracle answer that we checked is available, we will check is the response equal to the account that we expected. If yes, this is true. If not, this is not true. So we will pass none again. And then we can execute that check query function that we defined here. For all of the queries that we previously put in the state. So we look up for our URL, all the queries that we persisted earlier when we posted the queries. We check each query before we check for the result, only if the oracle is also checked. So we call this function for each of the checked oracles, and then it will be fine. And then when we've gotten all of the oracle answers with that function earlier, we will check again, have we gotten enough answers in order to trust it? So in Superhero, a minimum of answers have to be given in order to trust the result. And then we will see, is it positive or negative? So if it's provided, it's positive if the address is matching up. If it's not provided, we assume it's negative. We will check what's the length of that answers and do some math calculation. What kind of percentage? So the length of the answers times 100 divided by the length of the answers is the percent of positive answers. And if greater than 50% of the answers are positive for that URL contains that account, our thing will succeed and we will persist the success in the state. And also clean up our after selves, we will delete all the queries that we've done and persisted not to spam the blockchain. So that's how we use it in Superhero. This code here is quite complicated, just to make it small and concise. So I don't expect you to understand that perfectly from the first time looking at it or me guiding through for the first time. But if you want to have a look later on, it's also here in the slides. So that's it for our workshop on how to use oracles. And we can go back to any questions if there are any, or I can show some more things if you need them.
There are some pending questions from Nafis. Is using multiple oracles more time consuming than using a single oracle?
So generally, each oracle takes some time to answer. Yes. From this, it is more time consuming on the blockchain. But when you use the query in the smart contract, we query all the oracles with one transaction on the blockchain. This is not more time consuming or marginally more time consuming than checking a single oracle in using a contract. And therefore, this does not matter. And then all the oracles operate independently. So they run in parallel, provide their results, and we can check back in the same time as we would check back for a single result and then check all of the results. So for the user, it does not take more time.
Then there's a longer question from AKCE5. Wait, this flew away here. Okay. Imagine that I want to build a simple decentralized insurance system. Users pay a premium to start a smart contract for their flight being late. If the airplane is late, then the fee will be paid out. This check of the airplane is done externally, so if smart contracts can't be triggered by an oracle, which would normally do that check, then how can the recuperation be paid out?
So, for example, it can be a service that does it for you. In Superhero, what we do is there's a backend service that's running and performing these checks. It knows the answers have to be there by now, and it's anybody can check back. So it's a public function to apply the results, and anybody can trigger that check back. For example, in your example, the user can go and say, check if my claim has been processed by the decentralized insurance. And he can just go check back, and this triggers checking the oracles. Have they provided an answer yet? If so, maybe apply a payout for the damages or for the insured amount, something like that. Or you can make it public, or so anybody can do it, or you can make it so it's a central service that just does this checks. It doesn't have to be trusted, but it has to perform the checks.
Then there's another question. Can I call an oracle from another oracle?
Yes, in general, you can combine all of the things in Eternity blockchain with each other. So you can make an oracle that then queries multiple oracles, for example. The question is, what's the use case for this? But maybe if you find one, you can also, of course, do it.
Then is there a library or maybe a website of oracles where we can search different oracles for our project?
Currently, there's no marketplace for oracles. This itself would be a nice project. Somebody build a marketplace that indexes different or provides different oracles, of course. For the price feed, I run an oracle on mainnet that's also documented in the repository that I've put the link to in the presentation. So you can use that for testing out your things. And on mainnet, there are all, of course, the oracles that are used by Superhero that can check if the Eternity public key is part of a website. And I think Bitcoin Swiss is also running an oracle to provide exchange rates from a central party. But I don't know what's the state of this. Maybe there's a separate announcement.
Then can I reuse an account for an oracle if the oracle TTL is overdue?
Yes, you can reuse the same account over and over again if the oracle expired or if the TTL is overdue or anything. Just use it again if the fee can be paid for.
Is an oracle fee required, or can the fee be zero?
To register, you have to put in the fee, of course. To post a query, you don't have to pay the oracle operator, but you have to pay for the transaction to be included in the blockchain. But the fee to the operator can be zero if it's specified like that. That's free for your use case.
Then Favor asks, what are the possible reasons if an oracle doesn't respond?
So if an oracle doesn't respond, maybe the service that will process the response is just not available at the current point in time, or maybe there is no response. Maybe if you ask something and there is no answer for that, maybe it does not respond, but that's up to the individual implementation. If there's a technical issue, for example, the oracle does not exist or you paid too little fee for it, the blockchain will let you know this is not a valid transaction.
Then Marco's asking, Or maybe Mark, you want to speak up yourself? I think that's the easiest.
Yes, can you hear me?
Yes.
Yep.
Just again about the aggregation of different prices where the oracles respond. So how would we do that if we get strings as response from the oracles? So we would need to take a large...
do it with strings.
So I would need to respond with an int value.
Just you have to use contracts to respond. And then you can use it with ints and calculate your result using ints.
Okay, but wouldn't it be possible to respond with something like ethos, where we don't have commas in the end or somewhere in between, and convert the string value to an integer and calculate on that basis?
Sophia doesn't have a string to integer function, but I think you can do it, convert it to bytes and then convert the bytes to integer some way. That's possible, but I would prefer and advise to do it using integers and contracts. That's the straightforward solution for that.
But how do I do that if I need the external? So
you can just make a wrapping contract around your Oracle things. Let's go. Oh, let's go. So,
sorry, just wondering about that.
Yeah, that's fine.
But according to the docs, there is a toInt function when I see it correctly.
String toInt, but not.
Yeah.
There is?
Yes.
Let's check.
At least according to the documentation. But I think that's up to date.
I just see a bytes toInt.
Okay.
There's an integer to string, but not the other way around, because there can be lots of things going wrong with that. And to use it for, if you look in the Sophia documentation, there's an Oracle interface example contract where you can make all of the Oracle transactions from a contract. So you can make a query and respond, providing a signature from your account. So you can just make Oracle respond, and then also use this example here is actually with ints as a response. So this can be just a proxy contract to give the data from a central source to your contract as an integer or as any type.
Okay, thanks.
That was a great question. I have a follow-up question. Can I ask?
Yes.
Thank you. So I saw that docs says that there is like two int and string to int function probably and split function. So I was wondering if there is a way to add up all the elements in an array and then perform the aggregation.
Of course, with integers you can do all the calculation in arrays you want.
Oh, great. So it would go like with some kind of recursion loop that we currently have available.
Yes, you can use the list dot. I think there's a list dot. Let me see. List dot sum, for example, that sums up all of the integers in a list.
Great.
You can define yourself a list.average or list dot whatever else, average function or mean function or any function that you want using recursion.
Got it. Thank you for wrapping it.
Then we have another question from Yinka. What happens to query fees that are paid to an Oracle after its TTL is overdue? Are they lost or can they be withdrawn?
Query fees are only paid if a response is given. So if no response is given, the query fee is never paid. It's only locked for the time of the TTL. If during the TTL of the query there's no response given, you automatically receive the funds back. So you cannot lose it, and you don't have to do anything to get it back. If a response is given, it's automatically claimed for the operator.
Then we have still some questions from the beginning when the connection was lost that I still have here pending. Does registering a chain in the AES make use of oracles for the pre-check process?
No, it does not. It's internal to the protocol, the checks that are performed there. There's no oracle needed.
Then is the TTL like the hop of packets TTL of routing? I think Sheetap asked this. Maybe if you're here, maybe you can clarify the question.
Yes, I don't understand that. Maybe you can clarify.
The same Sheetap also just asked here in the chat. So the query fees are on the operator's account, and those fees can be claimed, and if by whom?
So when there's a query fee provided, the Oracle operator receives them automatically when he provides a response. And as I said in the beginning, if you register an Oracle, the account is used for that Oracle. So the account the Oracle has been registered with is getting the benefit of those query fee once the response is posted. Automatically, you don't have to do anything to receive them.
And I think the last one I had pending was from Gyan. What's the difference between an API from an exchange versus an Oracle? I think like the Oracle price feed that you showed before.
So the Oracle price feed you can use in a smart contract to make an automated decision. The API from an exchange you can only use in a centralized service, because you cannot query HTTP APIs on the blockchain. So it is building a bridge, and building a bridge how you wish it to be. This is how you define it with the Oracle.
Then another question came up. Can we create a custom Oracle system, restricted event-based, for example, for this hackathon, or we should use the existing system?
So this system that I presented now is the default one on the Aeternity blockchain, and it's cheap to use because it's directly integrated in the node. It's supported by the node, and it's very easy to use in a smart contract. But of course, it has some limitations. So if you want a cheap and default solution that's well integrated, use that one. If it does not fulfill your needs, maybe it's also good to write for example, an expansion protocol for more advanced Oracle system based on smart contracts. Of course, that's possible. But I think the easy solution is to just use the default Oracle system, as it's very well integrated. Okay, perfect. Thank you.
Yeah, there were like so many questions today. It's like really amazing, Philip. Like you did a great job. Like,
thank you.
Is there anyone?
If there's any more questions, you can of course ask them in the forum, and also you can ping me in Discord. I'm sometimes available there if there's any further questions, and I will later send out the presentation via Eric or Omar. You will receive it, of course, to look back at it, and there's also the links to the projects that I've shown.
Perfect. Thank you so much, Philip.
Okay, then. Thank you, everybody, for participation. If there's no more questions, I'm happy.
Yeah, Philip, it has been amazing. I'm reading comments that saying that oracles are much more advanced than last time that they looked, that this is so great, and that was so informative. So I learned a lot, by the way, even though I'm not technical. So thanks a lot for the presentation. It was awesome, and it's so nice to see all the interest and questions being answered. But hopefully, as Philip said, the forum is still there when we finish. Also, the Discord channel. So don't hesitate to post your questions or your doubts there. We will be happy to help. And yeah, I think we can wrap up for today. Get some more energy for tomorrow, in which we will learn about another of the unique features and advantages of Aeternity protocol, which is state channels, with Dimitar Ivanov from the Aeternity core development team. Tomorrow at 4, we will start this session. We hope to see you all there. And yeah, thanks a lot for being here. Thanks a lot for your participation and your interest and the projects you are building. Yeah, that's it. See you tomorrow, I hope. And thanks a lot, Philip, and thanks a lot, everyone. Eric for bringing the questions, Omar for being behind the scenes, and Nikita too. And thanks, everyone. Let's continue rocking.
Thank you. Have a good time, everybody.
The same.
Thank you, guys. Bye.
Thank you, everyone, for joining.